In this video, we're going to model with arithmetic sequences. The beautiful thing about arithmetic sequences is that they have a common difference. We're going to construct an explicit rule. I'm going to highlight that so I don't forget. An explicit rule in function notation for the arithmetic sequence represented in the table. Then we're going to interpret the meaning of a specific term of the sequence in the given context. Suppose the table shows the cost in dollars of postage per ounce of a letter. We have the number of ounces, 1, 2, 3, and 4, and we have the cost of the postage, 35 cents, 55 cents, 75 cents, and 95 cents. Well, I think the easiest thing to look at real quick is that we're going up by 20 cents. So we're adding 20 cents to get from one term to the next. That tells us that our common difference is 0.20. Our explicit rule says f of n equals the value of the first term, which is 0.35, plus the common difference, which is positive 0.20, times the quantity n minus 1. I'm actually going to simplify this by distributing and combining like terms. So I get f of n equals, there's an n in there, (0.20n) plus 0.15. So that's our explicit rule in function notation. Then interpret the meaning of a specific term. What would the value of any specific term mean? What does 35 cents mean? What does 75 cents mean? What does 95 cents mean? Well, each term, 35 cents, 55 cents, 75 cents, 95 cents, each term represents the cost of postage for n ounces of weight. And this is very interesting here. Let's go to a highlighter so that you can see. Each term represents the cost of postage. Each term represents the cost of postage. And the cost of postage depends on the number of ounces. And this is why we have a function. We have one quantity dependent upon another. Okay, let's try another. The table shows the cumulative total interest paid in dollars on a loan after each month. We want to write the explicit formula. So we have our common difference. We're going to add 70, add 70, add 70. That's a common difference. Therefore, we have an arithmetic sequence. D is equal to 70. The value of our first term is 160, and we're going to add 70 times the quantity n minus 1. We'll distribute that 70. We'll combine like terms, and we get 70n plus 90. And that's equal to f of n. And what does each term represent? Each term, f of n, represents, can you finish it before I do? It represents the cumulative total interest paid after n months. Okay, let's see if you can try this. And when you're ready to see if you've got it, press play again. Okay, you ready? So for our function, I started out with f of n equals 20 plus 12 times the quantity n minus 1, which simplified to be 12n plus 8. So f of n equals 12n plus 8. When I evaluated f of 10, I got 128, which means that 128 miles from the store after Mila traveled for 10 hours. So f of 10 equals 128 means that Mila is 128 miles from the store after she's traveled 10 hours. Okay, let's be given a graph and see if we can go backwards. So we've got ordered pairs 118, 217, 237 rather, 356, and 475. Our first value is the term, which is the number of weeks. So the first week, the second week, the third week, the fourth week. And after 1 week, we've collected, or DeAndre has collected, 18 feather pens. The second week, he's collected 37 feather pens, and so on and so forth. So I want to represent this in a table. So I'm going to have the number week and the number of pens. So the number week is 1, 2, 3, and 4. And the number pens is 18, 37, 56, and 75. Now to get from 18 to 37, we're going to add 19. And to get from 37 to 56, we add 19. And to get from 56 to 75, we add 19. That tells us that our common difference is 19. We want to write this as an equation. The explicit equation is f of n equals the value of the first term plus the common difference times n minus 1. And the recursive, just to bring back recursive, just want to make sure that you remember what recursive is f of 1 equals 18, comma, f of n equals the previous term plus 19. Now that you've got that, we're just going to kind of put that aside, and we're going to go with this one right here. So we've got f of n equals 18 plus 19n minus 19. This one's so much easier to use, right? Because I need to find the 12th week, and I don't want to have to figure out the 11th week and the 10th week and the 9th week and the 8th week and the 7th week and the 6th week and the 5th week to make that happen. I want to be able to use my explicit formula, which says just go ahead and put the 12th week in. So we get 19 times 12, and then we'll subtract 1. So 19 times 12 is 228. 228 minus 1 is 227 pens in week 12. Ta-da! And that's how we work with arithmetic sequences in real-world models.